All right, so let's get started on the example. So the first one, we have the series from n is equal to 1 to infinity of 1 over 10 to the nth. So remember, we're trying to get every series into this form where r is inside the parentheses, and then we can tell that if the absolute value of r is less than 1, then the series converges, and if the absolute value of 1 is greater than or equal to 1, then the series diverges. The way that I remember this is I think of geometric as like geometry, and then I think, okay, geometry is less than calculus because I like calc more than geometry. So I always think, okay, less than converges. I don't know. I do like word association. That's how I remember my stuff. You do you, okay? So in this case, I can rewrite this so that it's 1 over 10 to the nth power. And that makes sense because that means that it's 1 to the n and then 10 to the nth, and 1 to anything is still 1. So you end up with this. So use your rules of exponents. And then now you have it so that your r is 1 over 10. So r is equal to 1 over 10, but then the absolute value of r is equal to the absolute value of 1 over 10, which is 1 over 10. And we know that that's less than 1 because you're literally taking 1 and you're dividing it. So you're making it smaller. So it's going to be less than 1. So therefore this series converges. Now, because it's a geometric series, because it has an r, we can use a formula, a 1 minus r, to find what it converges to. So remember, the only time you can actually find what a series converges to if it's geometric or telescoping. Okay, because if telescoping, we can do it manually. Geometric, there's a formula. So A is your first term. So what is your first term? Well, your first term is when n is equal to 1. This here tells you what your first term is. So you plug in 1, so then you just get that your first term is 1 over 10. And so then you know that your r is 1 over 10. Now make sure that you don't plug in the absolute value of r. In this case, it doesn't make a difference. And instead, you plug in your actual r, okay? Not the absolute value of r, but r. So then this is 1 over 10 divided by 9 over 10, which is the same thing as multiplying, by its reciprocal. So that ends up being 1 over 9. So this series converges, but it converges to 1 over 9. This one we can rewrite as 2 over 4 to the n power, right? Because you could just pull it out. This simplifies to 1/2. R is equal to 1/2. The absolute value of r is the absolute value of 1/2, which is still 1/2. And that's obviously less than 1 because you're taking 1 and you're dividing it. Series converges. What does it converge to? So take your first term. 1 minus r is 1/2. And your a, what is your a? Well, your a is when n is equal to 1. So that's literally just 2 over 4, which is 1/2. 1 minus 1/2, that's 1/2. We have 1/2 at the top. So this series converges and it converges to 1. The next one, this is easy. It's already in this nice form where r is equal to -2. So the absolute value of r is equal to the absolute value of -2, which is 2. 2 is actually greater than 1. This series diverges, and therefore because it diverges, it has no sum. You can only find the sum if it converges, because then we know that it converges to something. In this case, it doesn't converge to anything, so there is no sum to find. So we move on. The next one, this we can rewrite as 1 over 5 to the n, like that, and then that's 1 over 5 all to the n because it's the same thing. So then you know that r is equal to 1 over 5. The absolute value of r is equal to 1 over 5. So then 1 divided by 5 is obviously less than 1. So then this series converges. Because it converges, we can find what it converges to. So a is our first term. Our first term is when n is equal to 0. Anything to the 0 power is 1. So this is literally 1. And then 1 minus r is 1/5. So if you do the math, right, 1 minus 1 over 5, that's 5. That's 5 minus 1, which is 4 over 5. So this is 4 over 5, 1, which is the same thing as 1 times the reciprocal, which is 5 over 4. So this converges, the series converges, but it converges to 5 over 4. This one is easy because our r is this. So our r is equal to -3 over 4. And so the absolute value of r is equal to -3 over 4 as well. And so 3 over 4, 3 divided by 4 is obviously going to be smaller than 1. So this is less than 1, so therefore this converges. Because it converges, we can find what it converges to. Take r is your -3 over 4, not the absolute value of r, but just r. So that's going to be -3 over 4. And then your a is your first term. Your first term is when n is equal to 3. So you go ahead and plug in 3. You're going to get -27 over here. And so then we say it converges, but it converges to -27 over 16. Next, we have this one. This one is really good because this is like using the second method that I showed you in the previous video, and that is rewriting it in its list form, because this is not really easy to tell what the r is. Like, you can't really put it in this notation. It's not as easy, right? Or it's not as apparent. So n is equal to 0 because the first term is 0. When I plug in 0, I get cosine of 0 over 9 to the 0. So that's just 1. And then cosine of 0, 0 here, this is 1, 0 is 1. So this is just 1, which is literally just 1. Then n is equal to 1. Oh, this is a series, so we add. When you plug in n is equal to 1, you get cosine of pi over 9. When you plug in n is equal to 2, you get cosine of 2 pi over 9's, just 9 squared. You don't have to simplify. N is equal to 3. You go ahead and plug in 3. You get cosine of 3 pi over 9 cubed, and then that goes on forever. A is easy. A is just 1. That's your first term. And then r is your common ratio, so ask yourself, what is the pattern? You could ask yourself that, or you can literally just divide the second term by the first one. Before doing that, I would simplify. So cosine of pi, that is negative 1, 0. So that's going to be negative 1 over 9. So if I take negative 1 over 9, divide that by 1, second term divided by the first term, it's literally just negative 1 over 9. So that is our r. So then I say, okay, well, the absolute value of r is the absolute value of negative 1 over 9, which is just 1 over 9. And that is less than 1. So therefore, this series converges. And because it converges, I can find what it converges to. So I know my first term is 1. My r is negative 1 over 9, which just becomes positive 1 over 9. And so that's 10 over 9. This is the same thing as multiplying by the reciprocal, so the answer is 9 over 10. And so we say that the series converges, but it converges to 9 over 10 by the geometric test. This one requires an algebraic trick, so just like we have like fractions like this, we can set that to be, 4, 2 plus 3. So same thing, if we have 5 to the n minus 2 to the n over 6 to the n, well, that's literally the same thing as 5 to the n 2 to the n, just split it up, right? So we can go ahead and split it up. So this becomes a series of n is equal to 1 to infinity of 5 to the n over 6 to the n minus 2 to the n over 6 to the n. And using your series rules, you can separate these. So this becomes n is equal to 1, 5 to the n, 6 to the n minus the same thing. All right, so you treat these as two separate series, and you have to find that both of them converge in order to actually find the sum. If one of them diverges, then the whole thing diverges, okay? So then this, you can treat it as 5 over 6 to the n. So then your r is equal to 5 over 6, with the absolute value of r is literally the exact same thing. So 5 divided by 6, that's obviously going to be smaller than 1. So this converges. Then this you can treat as 2 over 6 to the n, which is just 1/3 to the n. So your r is equal to 1/3. The absolute value of r is the same thing. That is obviously less than 1 because you're taking 1 and you're dividing and making it smaller. So this converges as well. Great. So then now that you know both of them converge, you can find the sum for each individual one and then subtract them because there's a subtraction sign here. If it was a plus, then you would add them. So in this case, the sum for this one is, well, I know my r is 5 over 6. And then I know my a, when I plug in my first term, which is 1, that's also 5 over 6. So do the math. 1 minus 5 over 6, that's 6. That's 6 minus 5, that's 1 over 6. So we have this as being 1 over 6. So we have this as being the same thing, just multiplied by its reciprocal. So we get 5. So it converges to 5. Well, actually, let's just say it converges, and then we're going to say 5 minus. All right, and so then the same thing over here. So a, 1 minus r. Our a is our first term. So when we plug in 1, that's 2. The first power, that's 2. 6 to the first power is 6. So that's going to be 1/3. But then we have that r is also 1/3. We do the math just to show you the work. That's 3 minus 1 is 2/3. So that's going to be 1/3 divided by 2/3, which is the same thing as multiplying by the reciprocal. This cancels out. You're left with 1/2. So this is 5 minus 1/2. We go ahead and do the math. That is 10 minus 1, that's 9 over 2. So we say that this series converges, and it converges to 9 over 2. If one of them diverged, if this converged and this diverged, then this series would diverge, okay? They both have to be convergent in order you to find the sum in the first place. Moving on to the last one, it's the same thing. we split it up. So this becomes the series n is equal to 2 to infinity, 3n to the 7n minus that. And then using our series rules, we can split that up into two series. All right, and so then this becomes 3 over 7 to the n. This becomes 5 over 7 to the n. This means that our r is 3 over 7. This means our r is 5 over 7. This means absolute value of r is literally the exact same thing. And I know that 3 divided by 7, right, that's obviously going to be smaller than 1. So let me make some room here. This is going to be less than 1, so this is going to converge. And this is also going to be less than 1, so this is going to be convergent. So now that I know both of them converge, I know that I can find the sum. I do it for each of them. So I already know that my r here is 3 over 7. I already know that my r here is 5 over 7. And then my a is my first term. So when I plug in 2 here, that's going to be 3 squared, that's 9. And 7 squared, that's 49. So 9, 49. And then my first term, when I plug in 2 here, that's 5 squared, that's 25 over 49. If you subtract these, you're going to get negative 41 over 28. And so you say that this series converges to negative 41 over 28.